Hello all, in this video we will solve some question based on MOT. MOT is molecular orbital theory. So in this case the anti-bonding electrons in NO and CO according to MO theory are respectively. Here are the options. For this we should know the MOT for the NO and the CO. The next thing is, for NO, nitrogen has 7 electrons we can say, and oxygen has 8 electrons. We are counting of the total electron, not the valence electron. So 7 plus 8, when you add them, we will get 15. Okay, so NO has 15 electrons total electrons, it is 15. And for carbon monoxide, it is for carbon it is 6 electrons total, and oxygen has 8 electrons, so 6 plus 8 will be 14. Now remember, when we are drawing the molecular orbitals up to 14 electrons, we have one molecular orbital, and above 14 electrons we have another, or the second molecular orbital. I will show it to you all now. For carbon monoxide, we can use this MOT, carbon monoxide. Why we can use for carbon monoxide? Carbon monoxide total electrons was 14. So MOT for molecule up to 14 electrons. I am talking about diatomic molecules. For up to 14 electrons, we can use this MOT. Now regarding this MOT, I will explain this. If you know this part, you can skip for a little bit for the ahead part. Here we are having 1s. This is atomic orbitals of one of the atom, and this is the atomic orbital for the next atom because it is diatomic. And here the boxes you can see, this is the molecular orbital. Now 1s they meet, and we get a bonding sigma 1s orbital and a sigma star 1s orbital. This is anti-bonding orbital. Same with 2s. Now regarding 2p orbitals, we have pi 2py and pi 2pz. Okay, these are pi orbitals, and then we are having here sigma 2px orbital. Now here this is anti-bonding orbitals. These are bonding orbitals and these are anti-bonding orbitals. Anti-bonding orbital for pi star 2py, pi star 2pz, and here sigma star 2px. So this is up to 14 electrons. Now what happens above 14 electrons? What will be the changes in above 14 electrons? Nothing, just these two will swap places. Just exchange these two places and you can use it for above 14 electrons. Hope I am clear. If everything remains the same, just these two places you have to swap or interchange, you get for above 14 electrons MOT. Now let's start filling for carbon monoxide, which is 14 electrons. We have to use the Pauli's exclusion principle, Hund's rule of multiplicity, etc., etc. So here 1 electron, second electron, third electron, the fourth electron, fifth, sixth, seventh, 8th, 9, 10, the 11th electron, the 12th electron, 13, 14. Okay, so 14 electrons are done. Now the question is anti-bonding electrons in CO and NO. Just now we are considering the case of CO. If you go back to this MOT, in MOT, if you can observe, there is no electron in this anti-bonding orbital. There are no electrons in anti-bonding orbitals. So here in this case, the anti-bonding orbital is considered to be 0. So for carbon monoxide, it is 0. Now if you are observing, NO is first, CO is second. If you observe the options, only this option has 0. So option A is the correct choice. But I will show it to you all how this is one for NO. For NO, you can use this MOT. This is above 14 electron. The only thing is that I have interchanged these two places. The rest, all the energy level remains the same. Now for NO, I just calculated it to be 15 electrons. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So if you can observe the 15th electron, it is entering the anti-bonding orbital here. So number of electrons in anti-bonding orbital will be, this is I can say anti-bonding orbital will be 1. So if you get back to the question, here it is 1 and 0. So option A, it is the correct choice.